Hi everyone, welcome to our afternoon session. So this is our main paper presentations, and they're submitted from all over the world on topics from education with App Inventor to technical innovations with App Inventor. And the format is they have about 10 minutes to do their presentation and then 5 minutes for Q&A. So we really invite you to ask questions. So our first presenter will be Pierangelo Andolfi from Italy. Please give him a warm welcome.
Thank you, Natalie. Good afternoon, everyone. I'm here because 40 years ago, I made a choice that many people thought was wrong. I stayed in Bari. Bari is a city on the Adriatic coast of southern Italy. If you look at a map, it sits at the heel of the boot, the part of the country that has always been called the South, with a capital S. In Italy, that phrase carries a weight that is hard to translate. It means a place of extraordinary culture and talent, and at the same time, a place that has historically exported both. Its best minds have left for Milan, for Turin, for London, for New York. The pressure on a young person with ability is not subtle. You are told in many ways that your future is elsewhere, that staying is a kind of defeat. I stayed. Back then, if you worked in computing in the South, you'd hear something like this: "You got the brains, well done, but stay close to home. A kilo of apples costs half as much down here, so eat your apples and be grateful." We wrote code anyway, and it had to work. Let's go back. In 1959, the year I was born, Domenico Modugno took Volare to the top of American charts. This is the statue of Domenico Modugno with this iconic position. Okay, probably you have seen. If you want, I can let you hear Volare. It's always a pleasure. To fly. It was a dream. To dream to fly. The same year, Italy produced the world's first commercial transistor computer. It was called the Elia 9003, made by Olivetti. In 1974, the electronics division was sold to General Electric, a decision still debated today. But the brains stayed, and so did something not so easily removed: the habit of creativity. In 1980s, in Bari, my town, in the Olivetti division where I worked, we wrote the BCOS operating system. We worked on personal systems and distributed computing at a time when the world was still debating whether personal computers were a serious thing. We made necessity a virtue. We turned an adverse context in an opportunity. Jump forward 40 years. Today, Bari is home to Deloitte, IBM, Accenture. They came here because they found the brains they were looking for. In 2025, Deloitte opened a new site aiming for 2,000 hires. IBM has a client innovation center focused on IoT and AI. The habit of creativity had not been removed. It had just been waiting for the right moment. Here is the paradox. The education system still can't keep up with this demand. There aren't enough young computer scientists in Apulia for the position available. The gap isn't about talent, it's about the system. Then I moved into teaching. Technical high schools in Bari, same logic. Take the students in front of you with the place and the problem they come from and build your computer science teaching out of that. In 2023, two of my students won the MIT App Inventor Summer Hackathon with an app for air quality monitoring. They came from backgrounds the system tends to push to the margins, and yet they won, competing against the world, and the award came from here, from MIT. The problem your app needs to solve has to be real, local, urgent, to you. If it is, motivation takes care of the rest. From this trajectory, I have drawn three principles I call peripheral innovation in computing education. First, context as an active pedagogical variable. The territory isn't a neutral backdrop. Its problems, air quality, the digital divide between generations, become objects of computational design. Second, educational continuity as a multiplier. I worked with a 10-year-old in a primary school in Putignano, a little town near Bari, with teenagers, with teenagers in technical high schools in Bari, with the university students at Politecnico. The same approach works at every level. Start from a concrete problem, build something that works, formalize it afterward. The continuity isn't in the tool, it is in the method. Third, the role of the teacher. Teaching computer science in a peripheral context isn't just about giving lessons. You become a connecting point between worlds that wouldn't otherwise talk to each other. Local institutions, regional grants, international competitions like this one. I was the link between a kid from Bari and MIT, not because it was in my contract, because it was the only way to make a difference in a context where the networks didn't already exist. These aren't principles I worked out on paper. I drew them from years in the classroom. And as I realize now, they were already there in Bari in 1980s. We just didn't fully know it yet. But I want to clear about something. This framework is not about Bari. It is not even about southern Italy. None of us chooses the time or the place we are born into. Some of us arrive in contexts that the world has decided are peripheral, geographically, economically, culturally. The question is what you do with that pressure. In physics, when you pull an elastic band back as far as it will go, you are not weakening it. You are storing energy. The further back you pull, the further forward it will travel when you release it. Peripheral context work the same way. The compression is real, the disadvantage is real, but if you find a way to absorb the impact instead of simply resisting it, that energy does not disappear. It becomes propulsion. This is what I mean by peripheral innovation, not resilience as endurance. Resilience as a slingshot. There is something I have to say now here, because I can't stand here and not to say it. In 2024, the Italian Ministry of Education banned smartphones in primary and middle schools, even for educational activities. It means that to teach with App Inventor is out of law. In 2025, the same ministry adopted the new STEM guidelines that explicitly promote digital coding across every school level, starting from primary school, citing as a scientific reference Italy National Inter-University Consortium for Informatics, banning the mobile device while introducing coding into the curriculum, signed by the same end 1 year apart. I'm not here to make a political point. I'll assume good faith on the part of whoever made that decision. But if there's a problem, it's the unconscious use of the smartphone. When we teach students to program these devices, we turn a passive consumer into an active builder. UNESCO has been saying this since 2010. A device is just an object. What matters is what you do with it. In 1975, 50 years ago, I started studying computer science at a technical school in Bari. My relatives asked if a computer was some kind of a very complicated television. I chose to stay in the south when almost everyone was leaving. I wrote code in Bari when people said the place was dead. And I kept teaching, believing you could do technology with the sea in front of you. I'm here because that choice wasn't wrong. And for those who had to leave, there's always a way back, home with the sea on your left. Thank you.
Diego, if you could come down to start getting set up. We may have time for 1 or 2 questions if people have questions.
I don't know if I have been too long.
2 minutes.
Okay.
So I guess I'll ask a question while Diego gets set up. Have you seen the student motivation change in your 40 or 50 years? Or do you feel students are always motivated, regardless of the time?
We are mentors. We have to motivate students. Probably if you, instead of a frontal lesson, you give them the possibility to touch the things. For example, with the App Inventor. if you can use the laboratory, if they solve problems that are their problems. For example, the air quality is a problem, a concrete problem. We have near Bari, there is Taranto, where there is there is very much pollution, okay, and the children become ill with cancer, okay. So if we understand this, our students realize that they study, that it is useful to study, okay.
Grazie, signore. Diego?
Thank you. Preso tutto? Sì. Grazie. Prego.
I'm going to butcher your last name, regardless of the fact that you've told me numerous times. Diego Barreiro is from Spain, but he currently lives in Ireland. He, as you heard in the panel, learned App Inventor in high school and then co-founded Codular and has been a contributor to App Inventor for a number of years now. We are very excited for all of his contributions and the work that he's going to be talking about today.
Do you know which one it is?
No, I have it downloaded because I changed it. So it should be, you have the browser here?
I don't know if we've got robust internet, sadly.
Please work. Yes, can you download it? We have internet. So this one, now.
What'd you ask me?
Where is the downloads? You know, up here. And to display, I think it is full screen mode.
Do it.
And can you try to use?
And this is a laser pointer.
Yeah. Good. Hello everyone. Is it audible? Cool. Hi everyone, my name is Diego Barreiro Perez. Thank you, Ivan, for the introduction. For the ones that were not here in the panel, basically I come from Spain, but I work full-time in Ireland. And to share a bit more about my background in App Inventor, so I started coding with App Inventor in 2014 in high school. Actually, I wanted to skip an exam. The teacher said, you can build an app with App Inventor and then you can skip the exam. And that's how I got into App Inventor. And then from there, I actually kept building more apps and then eventually transitioned as an open source contributor. I've been a Google Summer of Code student, and then I've also been a Google Summer of Code mentor. And in parallel throughout these years, I co-founded Codular in 2017, that is like a platform based on App Inventor. What I'm bringing today here is how, since February, I've been working on building an AI agent for MIT App Inventor. So what I'm going to cover today is, first of all, introduce what an AI agent is. So just a quick question, how many people know what is an AI agent? Okay, not everyone, cool. Then I will cover the design principles around how it has been built, then move on into the specific approach that I want to follow when it comes to integrating with App Inventor, and then we can have a QA round around any questions you may have about that. So first of all, what is an AI agent? So an AI agent, we can see it as like a piece of software that we have created to use AI into achieving specific goals. So for example, we can have an AI agent to help us coding, or we can have an AI agent to develop mobile applications. That's the definition that Google Gemini gives us when we search on Google. So there are plenty of AI agents out there, like Cloud Code, Codex, Cursor, Copilot. However, they don't really fit App Inventor that much, mainly because they are built for achieving the final solution, whereas in App Inventor, we want to try to teach people the process and making sure that people understand what they are doing and not just getting to the final solution in the end. So the existing tools are actually not really fitting this purpose. And what I was trying to achieve is actually making sure that we can explain and not just autocomplete. So the answer to this question is we have achieved this using an advisor-first approach. So the AI agent can actually do everything, can build applications, but the main focus is on the advisor approach, that it can help and guide people around when explaining things. I will now jump into architecture. Sorry, it's a bit technical, but I will be happy to answer questions later about that. So first of all, the first principle here is we have a clear separation between the server and the client. So the server, we can see it as the piece of software that interacts with an LLM provider, and then the client just applies operations as the AI decides to do. Then something interesting is that the AI is going to interact as a person using App Inventor would do. So if you open App Inventor, you're going to drag and drop a component, you're going to code some blocks, you're going to change some property. So the AI is also going to have the same kind of operations that we have normally. Then we have also the principle of preview before apply. We don't like when AI just goes and does something and we cannot actually see what they did. So in here, in this screenshot, what we can see is kind of a preview changes where we can see that it tries to set a new title and also add a new component to the app, so people can actually choose between applying it directly, rejecting it, or anything else that they want. So people can actually see before they apply the things. Then we have a modular context, so we have to pass quite a lot of information to the LLM to make it sure that it understands what App Inventor is. So we have to pass things like the project information, the screen, the catalog, and even the tutorial that the user may be following, or even the companion. And I will actually jump into those two topics later on. And finally, this has been built in a way that we are completely agnostic to a specific provider. We can use ChatGPT with OpenAI, we can use Cloud with Anthropic, or we can even use local models as well in case we want to save money, let's say it that way. So what it can do, we have to actually separate two different things. We have to separate reads and writes. So in terms of reading, the LLM is only going to receive the list of components, for example, but it has to discover all the things that the components can do, all the blocks, all the properties. So there is kind of a tool call that the AI can do to discover all of that. The same applies for the screen. So the LLM can only see what the user is seeing. So there is another tool available for the AI to actually figure out other screens in case the user is oh, I'm actually viewing a screen one, but it's asking about a screen two. So the AI can actually look it up in case it's needed. And finally, it can also understand what we are testing in the mobile phone. So when you actually open the app in the companion, you can play with the app, we can touch buttons and all of that. So the AI is actually aware of all of that and can help to provide better answers based on the interactions. And then we have what I mentioned on the right part of things. And there is actually this extra thing that is planning and executing. So for more advanced people that are more into the vibe coding side of things, they also have the option of orchestrating multiple AIs in parallel and modify different screens in parallel. But that's more into the vibe coding side of things. So how do we achieve this advisor-first approach? By separating the modes. So there are three modes. We have the advisor mode, that is the read-only. And then we have two write modes, the screen editor and the project editor. So when the user wants to open App Inventor and use AI, they are prompted with which mode you want to actually follow. In advisor mode, read-only, it cannot touch anything. And then the difference between a screen editor and project editor is that in a screen editor, it will only modify and try to access the current screen that the user is viewing, whereas in project editor, it can potentially navigate between screens or even use the plan mode that I just mentioned before. And how do we actually enforce that if the user is in advisor mode, the AI doesn't go and modify the project? So there are actually three different layers. So we have first a layer in the prompt side of things, in the system prompt, let's say. This system prompt doesn't tell the AI that they can write. The system prompt just says, you are just a read-only tool, you can only view things about the project. Then on the tool schema, this is the list of tools that the AI has available, like add components, set project, look up a screen. We just don't pass anything of that, so the AI cannot really discover those things. But let's say that the user, the student, is actually smart enough and they try to trick the AI with some prompt modification things, and they are able to make the AI hallucinate those tools. Then it's just fully enforced on the server side, it's going to completely reject those calls when they come back from the AI, so we fully guarantee that there won't be any edits in case the user is in advisor mode. So one cool feature of the advisor mode is the guided inspection. So when we code apps, we may be stuck around understanding a specific block. So for example, here, let's say that I don't really understand this block from a tutorial. I can just right-click on the block, click on explain block, And then the AI is going to actually explain me what this blocks does, how it interacts with other blocks, in case, for example, I'm following a tutorial and I don't understand some of the pre-existing code in the application. Another cool feature is that there is a nice integration with the tutorial mode. I'm not sure if everyone knows, but App Inventor has a tutorial sidebar that you can open a tutorial, and then you will have this little panel over here that has a step-by-step guide on how to build apps. So there is an integration with this thing that basically tells the AI that the user is following a tutorial, and then it's going to be able to provide specific things to questions like what's the next step. So for example, in this one, it's actually saying that there are these blocks pending to be built to complete the tutorial, or if the user is stuck in a specific step, it's going to be aware of you are on this step and you need to continue following this. And I think that one of the coolest features is the integration with the companion. So there are sometimes that we build the app and we are stuck and we face runtime errors. For example, trying to access an item in a list in index 2 and the list only has one element. So these kind of errors can happen. So the AI is going to be able to also help on this side of things. Basically, we may get a runtime error crash in App Inventor, and now we're also going to have a new button over here that is Ask AI, and this is going to actually be able to understand, first of all, what blocks are on the screen in particular, and then what things the user has written on the companion, as well as we are able to trace through the blocks what has gone wrong. It also knows things like the global variables, what they have changed, or the properties, how they have mutated after the user interacted with the mobile app. And just to wrap it up, I also want to mention some existing work. So Evan Patton and David Kim has been working on Apply for a couple of years already. And I think that one of the main difference here is that in Apply, you build the whole application, the LLM returns the whole code of the app, whereas in here, we are trying to make tool calls and try to mimic what the user is actually, how the user interacts with App Inventor. And that's kind of a bit different towards what Apply has achieved so far. And I think that's mostly it. Thank you, everyone. I hope it was nice, and happy to answer any questions.
Yes, so Diego will be doing a demo of this tomorrow.
Oh, yeah, forgot.
Demo
Sorry.
session. Yes.
Yeah, there will be a demo on this agent tomorrow in the demo sessions in the afternoon as well.
Yes. And while we take questions, Lyra, if you're here, could you come? Perfect. And just make sure everything's set up correctly for you. Do people have questions for Diego? If you could go to the microphone, please. Yeah.
So you mentioned, so you mentioned this AI as an agent.
Yeah.
So could it do more agentic things? Like, for example, could it edit blocks across the whole project, and could it do things like change cloud databases as well as tiny databases?
Yeah. So basically, the agent is fully scoped to the project. It will not be able to navigate between projects. However, the agent can actually modify blocks if you are in the project editor. So, for example, let's say that you have an event handler and you ask the agent to code something. It's going to be able to mutate that block and modify it so it fits what you actually ask it. Yeah, so the answer is yes.
Yeah. And so it can go around projects and take ideas. Let's just say I have a bunch of projects and I remember that I want to take a piece of code from that project. It's good.
You can do that technically now with the backpack.
Yeah.
You have the backpack, you can just drag and drop, but we can actually do that. It's basically just adding another layer on top of the agent so it can understand your previous work in other projects and potentially suggest you, oh, you have done this in the past, you want to maybe replicate something similar to that in the future. So it's possible, yeah.
Hi, I have a question about the AI agent. Does it work with extensions? So if I add an extension, how does it understand the extension when I add it?
It will understand it. So it's aware, actually I was doing some tests on extensions and it can actually know that you have an extension added to the project. So it will be able to interact with that. It doesn't tell you you have to import this extension because it doesn't know about the other extensions. Mm-hmm. But if you have the extension in your project, it's going to be able to know what components the extension has and what blocks and properties it has. So it will use the extension if you ask it to do.
Okay, thank you.
Hi, are we actually able to use it right now?
There is a demo tomorrow afternoon, but as of now, no, it's still under development. We may release it eventually, but as of now, we will just have the demo tomorrow to be able to test it.
I will say, with all of these challenges, the question is how do you pay for it?
That's a different topic.
Yes. Oh, Natalie.
So we are thinking about adding this to the classroom portal that we mentioned building for educators, because one of the, again, biggest uses of App Inventor is in education, and our current thinking is we want to give teachers the ability to control what level of access to the AI agent the students have. So maybe if you're a beginner, you don't want to start having an AI agent completely write your whole app for you, because that might undercut your learning. So you might want to start in advisor mode, and once you know a little bit more, then develop and get more access to these resources. So that's our current direction of thinking.
Any other questions for Diego? Okay.
Thank you, everyone.
Thank you very much, Diego. Okay, and so our next speaker is Lyra Logan. She's coming to us from the Florida Education Fund, and she's going to be speaking about what I thought was a very great presentation when I read it, the Mi Plato Dominicano.
Yes.
Take it away, Lyra.
Thank you, Evan, and good afternoon. I'm glad to be here today to talk about our project with Mi Plato Dominicana. It's a privacy-safe App Inventor image classification project for upper elementary AI literacy. And as Evan mentioned, I'm from the Florida Education Fund. I'm the president there. Our main program there is a doctoral fellowship program. So we come to working with App Inventor through our FEF Codemasters program, which is a pipeline to that doctoral fellowship program. But we do have a program context for why we wanted to work with App Inventor with very, very young kids, which is who we're dealing with now. Because about 4.5 years ago, we were asked by a funder in the Hillsborough County, Florida area to teach K-5 kids in Title I schools and parks who don't get any computer science education to come into the existing programs at the Hillsborough County schools as well as the county and city parks to teach coding 1 hour a day to these kids so that they would get that exposure, build some self-efficacy around learning, computing, and perhaps going on in STEM. And so for every semester since 2022 in the spring, we've been working with a cohort that's still with us. So that means in our minds that every single term we have to do something different. So we've got curriculum after curriculum using Scratch and block-based with robotics and sensor robotics and drones and animation and all of that. And frankly, our 4th through 5th graders who've now been with us for 4.5 years are needing a fresh challenge. And so I am an advocate for App Inventor. I'm actually one of the expert trainers that got trained under Karen Lang back in 2017, and Aaron, you were there as well. And so I'm an advocate for App Inventor, but I never have used it with elementary kids. So this was the context. We now need more curriculum. We need to move on to something a little more challenging. And so not the 1,300 kids that I was just talking about that we now work with in the schools at about 44 sites, but we have one partner who works with about 28 rising 4th through 6th graders each summer in a Spanish learning camp. And so every year we do their STEM programming as well. And so this year they asked for an AI project for their upper elementary kids. And so it gave us an opportunity to try this project with App Inventor, focused on their focus country for this year, which was the Dominican Republic. And so we brainstormed with them about a project that would have meaning and actually purpose for folks in the Dominican Republic. And so the project was to help users, to create an app that would help users fit Dominican foods into balanced meals using the USDA's concept of the My Plate, the balanced plate. And so that's what we did with these kids. And we just felt that our challenge was going to be whether or not we could hold the elementary school students' attention and also minimize the complexity of App Inventor while helping them realize how they could create something very meaningful and exciting. So our challenges where that Scratch had become, I think for our students in these programs, if they don't have something in their hand, even though with Scratch you can make fun games and play them, eventually if they don't have the robot or the drone, and now thankfully we found they like the phone, something in their hands, they're not going to be as interested. So Scratch had become less interesting. App Inventor, we knew, as another design challenge, was going to be more complex for them, and we would have to break that down. And then a self-imposed problem that we had, or challenge we had to surmount, is that we were teaching drones, which is our #1 bestseller, to the K-2 students who were leaving the classroom right before these kids were coming in to do apps. And so they're coming in with the younger kids jumping around and screaming after they programmed their drones, and we knew that they would want to do that as well. So that was a challenge we had to surmount with the app project, which we knew needed careful scaffolding and needed to just make it very plain for the students how important it is to be able to create something purposeful. So those are sort of our challenges. And so we implemented, you'll see in what I'm telling you, and if you read the paper, that we had to change implementation. And I'll tell you, we had 8 hours with the kids. That's all we had with them. There were 8 days that we came in for an hour each. We had planned to use all 8 hours, but at one point, the director of the camp said, I asked her, how's coding going? And she said to me, the kids are enjoying it, especially the kids with the drones. So I was like, okay, so I do have to make a provision for my older kids to play with the drones. And so we just took the project and made it 7 of the 8 hours. But anyway, each of the hours sort of built on the other. We did learn, like I say, we work with these kids or with this program every summer. We thought they would come in a little bit more advanced with coding because of that, but they didn't. So we did have to adjust for another region, which is because some of them had not even worked with event-driven programming, so hadn't worked with Scratch and didn't know anything about conditionals, and so those were going to be used in the final project. So we started with Talk to Me. I know you all are familiar with the Talk to Me app and how quickly everyone falls in love with App Inventor because of that app. And then we spent an entire day as a class training the model on the App Inventor pick, the image classification tool. So we did that as a group, and I'll talk a little bit more about that. And then we did a couple apps just to get the students, again, used to the components that they would need, the camera, the image, teaching some design and user interface concepts, and then also working with the if, then, and else if blocks. And then for hours 6 and 7, they built their app. And so model training, we were able to make somewhat engaging, obviously not as much as actually having a phone in your hand, which we didn't feel we could let them do, but it was a full class activity. We gave the students either wooden fruit or images of photos, images of food, to come up to our photo station for our teachers to take pictures of those items and add them to the model. And so we had pick up the image classifier up on the screen as we showed them the images we already had in, and then added from the phones these new images. So that's how we trained the model in front of the kids, and then had a really robust discussion about when the model failed for us, varied images that we should add, and then even input from them on cultural foods that they had learned about as they were learning Spanish with the Dominican curriculum that they were learning. And so it was a visible, immediate class activity. And so we trained with them the fruit and vegetable versus protein categories, and there were 3 categories all total that the model ended up including. But what was good about that 1 hour was that in it the model failed, as I mentioned before, in a very useful way, and we really do feel like we were able to relate some responsible AI principles to them. The reason it failed was intentional. We had trained it with only whole foods, so whole apples, whole oranges, and then tested it, of course, with sliced fruit, so that failed. And then it showed them, I guess when they came into it, like mostly with kids and even adults, AI was very magical and mythical, and as soon as they saw it fail, they realize it's something that they can teach and that they have responsible for making sure they teach with varied and balanced samples and examples. And so they did recognize that immediately. And then we were also able to get them to grasp that the model was a very helpful way of helping the project move along, because it meant that if we gave it the right examples, then we wouldn't have to actually, as in the olden days, actually code a fixed rule for each variation. And so they were able to understand that and understand the importance of varied and balanced data going into AI models. And so what they did build was the working ingredient scanner, very, very simple. And it would, the app scans single ingredients, then predicts one of the 3 food categories, vegetables and fruit, or meat, proteins or grains, and then it displays a balanced meal message. And so what was very heartening for me, because I'm always worried about the dreaded drones, was that some of them actually did. We gave them 1 piece of fruit or something to test their app after they completed it. And I was just so gratified to see that a lot of the students were very interested in it working, like really working. And so they wanted to test not just a piece of fruit, but they also wanted to test the other 2 categories. So that was a pleasant surprise. And also, we had, I don't know if it was ChatGPT or Gemini, but one of them generated several really cool images that they could use as their sort of cover image for the app. And a lot of them did that eagerly, and also were interested in just personalizing and having that creativity over the project. So what we did change from design to practice was, like I said, we went from 8 hours to 7. We're just going to do 2 simple App Inventor apps and then move into model training for a couple days, and then the final app. But we ended up, like I said, doing some scaffolding and just teaching more about App Inventor with 4 days of apps. And then we went from 2 model training days to 1. We felt it was sufficient. We felt that they got the responsible AI information that we were trying to relate. And then finally, we spent 2 days on the final app build instead of the 5 that we had anticipated. So we did this from June 1 to June 25th. So we just did this project. And I'm excited about it because, as I was saying, we do need more curricula for these kids. And so we feel that we now know that we can work with our upper elementary students with App Inventor, as long as we sort of, take them along with it and phase the skills in, and definitely have those phones in their hands because they just need something. And we were very pleased that the students were able to understand AI, specifically because they got to train it and understand that it is something that people train and work with and can improve. And then finally, we did notice that even these very young children enjoyed making something that had meaning, and they enjoyed using their own creative choices to do it. And it held their attention, except for the drone still won on pure excitement, so we had to give up a day. But Mi Plato was a successful project. So, any questions about Mi Plato?
Okay, we have time for maybe one question for Lyra. And Rishi, if you could please get set up.
All right, thank you.
So any questions? All right, I have one.
Okay.
How could you incorporate other, I know obviously the drones are very exciting, but I'm curious how you could maybe incorporate other physical technology into the food ecosystem, right? So like maybe a scale or something to kind of like show them a physical piece in addition to the phone. Have you thought about that?
We haven't thought about that. We probably will as we move into our next semester. Our next semester with the kids, we're in the office now building these mini smart homes. And so they're going to be doing IoT with a lot of the sensors. And perhaps there's something with refrigeration and food and making sure your food doesn't spoil by having some kind of temperature sensor that we might be able to work in. But yeah, we're
Where's Robert? Is Robert in here right now? Oh, because he did this where he put a sensor, a microbit inside of his refrigerator and used it to figure out when his daughter was leaving the fridge open.
So maybe we'll include that sensor with this next semester. But
Yeah, we'll have to send you some stuff. I think
yeah,
we can-
please do.
Yeah.
Absolutely. All right.
The scaffolding.
Okay. Yes, I can hear you.
So when we work with elementary school students, we find that they need, just because of developmental milestones, a lot more scaffolding than middle
Yes.
school and high school. Can you talk a little bit more about what scaffolding you provided?
Okay, yes, because we thought, I think with the 1,300 kids that we've been working with block-based and Scratch through all this time, I think they know now what event-driven programming is, and they know, they know when it's going to be used in these projects by now, as well as if, the conditionals and even loops and all that stuff. So they know that. But for this particular group who were pretty new to coding, we felt on both sides of the, I guess both tabs of App Inventor, we had to do a lot more with them. As far on the design side of the stuff you go through with how you lay out a nice looking app and some of the accessibility issues with the size of the font and the contrast and color and then all the properties and all that. But then on the block side, the blocks being more complex than Scratch, we knew that it just would make sense for us to get to an easy final project to go ahead and let them work with the camera, let them work with the image component, and just teach them the exciting mobile phone functionality, and let them see how the blocks work together, and then introduce the conditionals to them before we threw it into the starter app that we gave them for Mi Plato. So,
Thank you.
Let's thank Lyra one more time.
all right, thank you.
And next we have Rishi Muzumdar, who is coming to us from India and is going to be speaking to us about a project that he did with some young girls in rural India on cow health, I think, right? Yeah.
Thank you, Van.
Take it away.
Yeah. In India, when people talk, we talk about cows. But today we'll talk about cows in a different way. And some of it is about what we discussed in the morning, and we have been discussing for the past 3 years. It's about computational action. Am I audible? Let me turn up my timer. I'm very bad with time. Where did I go? The timer started. And I'm wearing this red today, so please consider this as a sign of love from the children. So they said that you should wear red. So I am wearing red for them. I'm representing them, but I worked with them during the last year. Just to give a bit of context, I am Rishi. I work with Quest Alliance. It's a not-for-profit in India, which works with government school children across today 6 states across the country. And a lot of our work is with the rural children, particularly the students who go to public schools. They are also called government schools in India. They are not like the public schools you see in Massachusetts or in any part of America. But a bit of context, these children come from a rural tribal community in a state called Andhra Pradesh. Some of you are Telugu, you must be knowing that language. So this is the story of those children and how they experience computational action in their own ways. I have often taken inspiration from the work of Seymour Papert and the work that has happened around this. Very recently, I've been reading about Marvin Minsky as well. And I've been wondering, what does it mean for a context like where I come from or where I work with? Even the context where I live and the context where they live are completely different. It took me years to really understand. So I'll go ahead with this. I won't take much time. I think all of us know that Seymour Papert spoke about this. This slide is from the first App Inventor Summit. So I just kept it where he talks about constructionism. Children learn best when they are actively engaged in constructing something that has personal meaning to them. But today I'm also going to talk about what does it mean to go beyond this personal meaning, what does it take to bring that into action. So this is a small village in Andhra. They make good coffee. I can share some of the coffees. This is slightly different from what you get here, but it's very interesting. But yeah, they are in the Mundla village. These girls have never written a piece of code. And for us, really letting them go through a problem-solving process was the first step. So I remember what Kelly was talking in the morning. The problem-solving process, the education part of the computational action is, yeah, these are the girls. The photos have been taken from their consent. So yeah, I also want to thank them for maybe trusting in all of us, because they come from communities where they are not even allowed to go out of their homes. They live in a government-run hostel-based schools called KGBB. It's called Kasturba Gandhi Balika Vidyalaya. And this project is part of the Hack to the Future hackathon that we do every second year in Bangalore. And this was their first experience of using App Inventor. Yeah? I also want to thank Samira, who led that state around that time for the state of Andhra. Yeah, I think this is what they said. They came to me and they said, we have cattles who are, wandering. Sometimes they go out of the boundary, they die. And second is that their illness gets undetected. I said, how is it that a problem? And they said, no, it's a problem for me and for my family and for my community, because it leads to loss of money, and hence, it really kinds of affects us all. So, and if you see in their community, 70% of the household income comes from the livestock. So basically, the animal is irreplaceable. Buying a new animal is itself a challenge. So they said, and this looks, completely, what they had seen is that there is a watch. Everyone wears nowadays a watch. And they thought about, how can I use this technology to solve this problem? I'll go next. They went door to door, did interview with the farmers, with their community, to understand, what exactly is the problem. They were not designed, they were not asked by some curriculum that you should follow this process. There was a lot of scaffolding that was needed, because to be able to ask questions is itself a challenge, and asking good questions when it comes to problem solving. So it is never prescribed by their curriculum, though now the state has actually formalized some of this work as part of the curriculum. But when this was happening, it was not. They said, okay, my client, when we talk about business, my client over here is my community, other farmers around. And they, of course, the lived experience was the data. So based on this, they said, okay, if this is what it is, how can I say that, normally through a design thinking process, we write these problem statements to be specific. So they said, okay, how might we help a farmer know their cow is sick or missing before it is too late? Which means they were trying to build an early warning system to detect the illness and also to see where, if the livestock is going. It may be very easy in a certain context, but in their context, it was completely different, because they had never thought of these technologies. Yeah, so here comes the app built on App Inventor. It's called MooCare. They have like a neck-worn IoT device. They took an inspiration from a watch-like thing, and they said, okay, how can I use this technology for, for this purpose? So it has GPS boundary alerts, which means if the cow goes out of certain boundary, it will give you an alert on your mobile phone, the App Inventor-based mobile phone app. It has one-tap veterinary access, which means if there's a threshold that a cow has reached in terms of their health, it will give a signal and you can reach out to a veterinary. This is still, it has slight defects, but yeah, it's still work in progress. But they said, okay, we will also take it to multi-species, which means it's not just the cow, can I take it to some other animals? Yeah, and this is an actual picture from that. They did a test, and this is how the interface looks like, 30 degrees, 80, the heart rate and all of that, yeah. But what I want to also talk about is that they said, okay, I will also try to personalize this, and that's where the thought of computational authorship comes. One is your thinking, but other is also how do you author it and make it your own. They said, okay, my father calls the animal by their name. So can I make the interface the way that my father, can relate to? So they said, okay. So their alerts are not that this, this cow number 1 is under this, has gone out of some boundary or something. But it is like this, that Lakshmi is near the boundary, Ganga hasn't moved in 3 hours, which means there's some problem. So, which means that you are using the data. It's like having a library app which doesn't count how many books have been issued, but what is your reading pattern? So they are really trying to understand what is the pattern. I know I have just 60 seconds. And this is what the App Inventor made possible. First of all, block-based coding, which means you don't have syntax barriers. It's very intuitive. Of course, there's block-based accessibility, but IoT extension support, low resource context ready also. And this is what we thought over a period of time, that from thinking to an action to an authorship. What does authorship mean? It means where you craft new knowledge through computation from lived experiences. Computing is an epistemic act, which means that you use computation to kind of construct your own knowledge, which relates to epistemology. Shaping what is knowable, not just what is buildable. Like I gave you an example, that you can build a library app to count the number of books, but what is knowable? If I am a good librarian, I would like to know how many of my students or how many of the students are really reading. What is the reading pattern? So I think, that's where I would say, this is how they're thinking of this AI-powered vision. And they want to use the phone camera for image recognition so that they can detect abnormalities. They are trying to see how much less hardware they can use, so they are very frugal as well, and we as a society are also very frugal, so we try to make sure that how much we can make from the best of what we have. I think these are the conditions that made it possible. One is that there was a really self-identified problem. No one asked them, we nudged them, but we never asked them that you should solve this problem. Oftentimes, some of these problem-solving processes becomes someone else's mandate. So it was not their teacher's mandate. And that required a lot of agency, and which requires a lot of effort of how you do your facilitation, how you make it a safe space for the child. App Inventor as the authoring tool, because it's so easy, so intuitive. You can make an app in the first 10 minutes. And then that gives a child a high, which means you have a very lower barrier to really build something. We had a public audience because this happened in 2025. There were like almost 60 students from all across the country. There was representation from the government. There was representation from the not-for-profits in India. So it made it. And all of you are welcome to come to India whenever you are. I'll myself extend invites. But yeah, it's very, very energetic to see these children doing some of these work. There is a program structure which is basically built around it, and there is a dedicated school time, which means it's not like after school I will do, because after school children want to play, they don't want to study. So how do we really make sure that it's part of their, and hence the pedagogy, which is the problem-solving process itself. I don't want to get into this thing, but yeah, you need epistemological grounding. Because we have seen that there are ways of knowing that these children have which we are not aware of, and hence we think that our way of knowing is at a higher pedestal, which we really have to remove that barrier through our facilitation. Otherwise, their ideas becomes very, very, they get caged in certain set of ideas. So how do we really make sure that their epistemology is taken into, So if we want AI that knows differently, we need builders who also knows differently. It's not about who builds. It's about whose ways of knowing builds that. Because there are ways that our child knows, maybe we don't know. And that makes this experience very humbling for me. You can watch this video in case it's allowed, do we? Sure. Yeah, absolutely. That's why I came, because it's an interesting video, but yeah.
All right, so Sakura-san, could you come down and start setting, and set up your computer? And then while we're switching computers, does anyone, maybe we have time for one quick question? Please come.
No, I think we are running.
Oh, do you want to play? I mean, how long is it?
I'll stop it in like 2 minutes, in case, yeah.
Oh, okay, yeah, we're a little over time, so.
నమస్కారం నేను యాష్మిని చెప్తున్నాను నా పేరు శ్రద్ధాంజలి మహంతి తెలుగుగా నా పేరు శ్రద్ధా మహంతి మేమందరం ఏపీ మోడల్ స్కూల్ ఎంఎస్పల్లి శ్రీకాకుళం జిల్లా ఆంధ్రప్రదేశ్ రాష్ట్రం నుంచి వచ్చాము ఇన్ ఇండియా ఆల్మోస్ట్ 2.5 crore cows are there. So every year farmers face like wandering cows and undetected illness.
ఎవరెవరి దగ్గర ఆవులు ఉన్నాయి దానికి వాళ్ళకి అడిగేసి వాళ్ళు చాలా ఎక్కువ సొల్యూషన్ చెప్పారు కానీ వీళ్ళు చెప్పినట్లు రెండు ప్రాబ్లం చాలా మాకు ఇంపార్టెంట్గా దొరికింది అందుకే దాన్ని సొల్యూషన్ చేసాం
అది వచ్చేసి నెక్ బెండ్ ఆఫ్ ద కవ్ ఇది ఆవు యొక్క నెక్ కి తగిలించడం జరుగుతుంది దీనిలో మేము చాలా సెన్సర్స్ పెట్టడం జరిగింది ఆవు యొక్క బాడీ టెంపరేచర్ ని హార్ట్ రేట్ ని ఇంకా దాని యాక్టివిటీస్ ని మనం డిటెక్ట్ చేయొచ్చు ఒకవేళ ఇది ఎక్కడ పోయినా సరే మనం GPS ట్రాకర్ ద్వారా దీన్ని ట్రాక్ చేయొచ్చు we made an app on the screen of the app we have the names of the cows and the number of the cow when we try to know about the cow we can click on the name of the cow this is not only for cows this is useful for many other animals if the farmer have any doubt they can go to the veterinary doctor and clarify their doubts veterinary doctor can track the progress of the cow
Okay, so maybe one question while we swap computers, if anyone has a quick question.
Speechless.
We do have a quick question. So about the cost, right? So you mentioned frugality and the cost of the device. What does it currently cost now, and where do you see it going to try to make it more accessible to other families?
In terms of the cost, they haven't done, but when it was being built, it was less than $10.
Natalie. Yeah, Laura.
I just wanted to say I love this. I've heard about this for a few weeks from other people, so it's been great. I am wondering how you channel students. A lot of time when I work with students, they come in with what I'll call the beauty pageant answer. I want to fix world hunger or these big problems that are really hard to solve. How do you get them to hone in on a problem that's solvable, that they really know about in and out, and then get them working on it? I'm really curious about that.
Thank you. That was a great question, Laura. Just for context, that we work in India with Raspberry Pi Foundation as well. And that's what I was telling in the very beginning, is that it's a pedagogical process that is important. You need to do sustained activity. And this is not, people keep asking, is this is this possible at scale? Because I'm sure your question may be coming from that scale lens as well. But there is a need of sustained training, teacher training. If I have to talk about this, this was not done just through teachers. It was a partial effort of teachers, at least at the level of the schools, because the level of challenges that we have in India are very different, and I'm sure other countries also have other challenges. But how do we do that sustained effort is going to be important, but from a pedagogical process, it is very important to do a good training of design thinking, of how really you want to take this through. So a lot of our curriculum that we are doing, and for your this thing, in Odisha also, this entire work, this entire pedagogical process is not separate. It is part of the curriculum itself. So you are not doing any pedagogical training separately, but your content itself is talking about it. So it's interspersed a lot through that. But these are very early signs. There's a lot of effort that we also had to do. It's like a 50-50 effort from the teachers and from organizations like Quest, RPF, and LLF, so many organizations. So yeah, that requires a different kind of effort. And it can't be scaled in just, and it will take some time. I'm holding my horses.
All right,
Yeah.
thank you very much, Rishi. And next we have Sakura Ando. She is going to be speaking on fostering awareness of one's behaviors through block-based coding.
Yeah, thank you. Hello, everyone. I am honored to have the opportunity to present here. My name is Sakura Ando, and I am a student at Kanagawa Institute of Technology in Japan. Today, I want to talk about our research, fostering awareness and noticing of one's everyday behavior through block-based programming. I worked on this project with Professor Kosuke Takano. Let me start my presentation. Today, we live in a computer and AI society. In this society, the development of logical thinking, computational thinking, and computational action skills is essential for children. However, developing these skills brings a high cognitive load for them. It is very difficult for young students to design logical flows without any constraints. Also, it is hard for teachers to provide simple and effective feedback to support them. To solve these issues, we set three purposes for our research. First, we want to develop computational thinking skills by making students think about their daily activities in block-based programming. Second, we want to establish education methods for modeling daily actions as structured programs. Third, we evaluate our system to see if LLM-generated feedback works well in AI simulations. This slide shows our approach. Before that, what is block-based programming? It is a method to create programs by connecting visual blocks like puzzle. It is widely used in Japanese elementary schools now. We describe user action plans using a block-based programming approach. This has high relevance and relatability for younger students because they program their own daily lives. Also, we use LLMs as a compiler or debugger for human action plans. This encourages students to notice their own logical flows by themselves. Block-based programming has three advantages. First, system constraints make it easy to modularize action plans into clear steps. Second, it visualizes invisible thinking process objectively. Third, it has a low cognitive load compared to text-based programming. However, as tasks become complex, students tend to make more mistakes. Therefore, timely feedback from AI systems is essential. This is our educational framework. Please look at this example. On the left side, it is target block. For each topic, it is set as a model for users to follow. On the right is a user-generated block. Here, the user forgot the repeat block. If you follow this plan exactly, you will only pick up one piece of trash, even if the room is still dirty. Our system uses an LLM-based compiler to check this plan and generate feedback like the text at the bottom. It points out action errors and potential risks. The diagram shows how the student and the system interact. First, the system gives a topic for the student. The student creates a process block using blocks. Then the AI model runs a simulation and returns the result. If there are errors, the system shows them to the student. The student fixes the blocks through trial and error until they achieve the intended scenario. Here is an overview of our experimental system. The front end is a web browser application built with HTML, JavaScript, and Blockly. The back end is a web server built with Python and Flask. For the LLM, we use the Google Gemini API. When a student clicks Simulation Start, the front end sends the block screenshot data to the server. The server handles the data, called the Gemini API. Gemini compares the target blocks and the user's blocks and generates simulation result. The server sends back feedback messages to browser. Here is a video of our demo. The topic here is picking up trash. First, the user made a program to pick up and throw away trash only once. So the LLM simulation points out that the user's action did not work well. Then, the user added a repeat block to repeat the action until there is no trash in the room. This time, the LLM praised the user and showed the successful result. AI said, "You did a great job." We expect three main contributions from this method. First, it can compile freely described action plans by leveraging the LLM as a compiler. Second, it significantly reduces the burden on educators because students can engage in self-directed learning. Third, it fosters metacognitive skills with a reduced cognitive load through visual programming and timely LLM feedback. To evaluate our prototype system, we conducted two experiments. Experiment 1 evaluates the performance of LLM-generated feedback during step-by-step construction. Experiment 2 evaluates the performance of the LLM across 4 different block construction states. The purpose of experiment 1 is to evaluate step-by-step feedback performance. For the method, we prepared target block images for 10 daily life scenarios. We simulated step-by-step construction and performed a qualitative evaluation of the feedback generated by the LLM. Like this, these are 10 scenarios we prepared for the evaluation. This slide shows our default prompt instruction for the LLM. This is a result example from the buy the juice scenario. In the example on the left, the user forgot to put enough money into the vending machine. So the LLM points out that So the LLM points out that the user cannot buy juice because they do not have enough money. In the middle example, the user put enough money but forgot to collect the change. The LLM returned a result saying that the user went home without collecting the change. In the example on the right, the user made exactly the same blocks as the target block. However, the LLM did not recognize that it was successful. From experiment 1, we confirmed that appropriate simulations of action errors and potential risks were generated based on missing blocks across all 10 topics. Detailed advice was generated. However, we found a new challenge. Excessive advice may hinder the development of users' logical thinking skills. Therefore, we must reduce excessive advice in the prompts. And next, let's move on to experiment 2. The purpose here is to evaluate the LLM performance in assessing constructed blocks across 4 block construction states. We prepared block images representing these 4 states for the 10 scenarios and performed qualitative evaluation. There are the 4 block construction states. State A is not enough, meaning user blocks are lacking relative to the target block. State B is perfect, matching exactly. State C is more detailed, meaning user blocks surpass the target block in appropriate detail. State D is partial replacement, where some steps are in a different, interchangeable order. There are the 3 or 4 construction states per scenarios we prepared for the evaluation. This is the result for state A, not enough. In the morning routine scenario, in this test, the user choose their clothes but forgot to put them on. We instructed Gemini not to provide the direct answer. As a result, the system successfully returned only the simulation without giving the direct answer. And this is state B, perfect. When user blocks match the target block exactly, we instructed Gemini to stop pointing out flaws and praise the user. The system successfully stopped prompting users for unnecessary details and gave a warm praise. This is set C, more details. The user added an extra appropriate step, check the temperature. We instructed Gemini not to point out errors if the flow is more detailed but appropriate. The system successfully began to praise users upon completion. This is set D, partial replacement. In this case, the user swapped the order to accessible steps, like eating breakfast before getting dressed. This order is interchangeable in daily life, but the system incorrectly flagged it as an error. This is an issue because the AI should judge these blocks as perfect. This table summarizes the result of experiment 2. For state A and state B, the system succeeded in all 10 situations. For state C, it incorrectly flagged detailed parts as errors in 2 situations. For state D, it incorrectly flagged swapped steps as errors in all situations. Therefore, state C and state D require further prompt improvement and fine-tuning if necessary. In conclusion, we proposed an educational design and method leveraging AI-based simulation to develop student ability to construct everyday behavior in block-based programming. Useful feedback was successfully demonstrated through prompt improvement. Our project is open source, You can access our prototype code and data on GitHub using this QR code or URL. Thank you very much for listening.
So while we switch computers, Ayaka, you can come up. We may have time for just one short question, if anyone has a question for Sakura. I have one.
Okay.
Have you thought about introducing abstraction into your block environment? So for example, pick up trash.
Yeah.
Right? If I'm cleaning my room, I want to pick up all the trash. But if I'm walking down the street, I maybe don't want to stop every 5 steps to pick up trash. So have you thought about introducing a block that would allow you to sort of give a higher level abstraction compared to what you currently provide?
Maybe I think this situation is type C, more details. So I'm sorry, I forgot your question.
A block for another level of abstraction above. So you put the repeat block inside for pick up trash, whereas I would expect I could maybe have a repeat block and pick up trash as an action inside of that. Maybe we'll talk offline. Is that good? We'll maybe talk later.
Someone talk. I'm sorry, I can't follow your.
We'll talk afterwards when we have more time.
Okay.
Okay. All set? Yes. Okay, and then our last presenter for this session is Ayaka and Takahiro, and they're going to be talking about the Japan Wagamama Awards.
Hey. Minasan, konnichiwa. Yeah, thank you. Hello, everyone. My name is Takahiro Yatsu.
My name is Ayaka Nagai.
From Irodori Inc. We are working in Japan, collaborating with schools, local governments, and community members to support young people in taking action. Today, we would like to share how we have been implementing computational action in Japan. Today, I would like to begin with the story of one student. Her name is Nanoka. She's a high school student from a rural area of Japan. 2 years ago, she experienced the Noto Peninsula earthquake. At the time, she felt completely powerless. She believed, there is nothing I can do. Today, however, Nanoka is working with local clinics, emergency responders, and city officials to put into practice an app that supports medical information sharing during disasters. What changed? How did a student who once felt powerless become someone contributing to her community? This question has guided our work over the past several years. In Japan, national education policies have increasingly emphasized preventing young people for a rapidly changing society by developing digital literacy, problem solving, and collaboration, and other skills for the digital age. However, our focus is not only on skills, self-efficacy. In a 6-country survey, only 46% of Japanese young people believe they could change society through their own actions. Skills alone are not enough. Young people must also believe, I can make a difference. That is why we created the Japan Wagamama Awards, to help young people realize, I can make a difference. my action can contribute to society. But we soon recognized another challenge: opportunities to innovate are not equally available. Students who participate in programming competitions or international events often already have strong academic backgrounds, technical skills, supportive families, or better access to information. Meanwhile, the young people who experience social issues most costly, through family caregiving, disasters, isolation, disability, or everyday challenges, often never have the opportunity to see their own experiences as meaningful starting points for innovation. Their experiences matter, but many of them never get the chance to turn those experiences into questions worth exploring. That is why we Japan Wagamama Awards began by finding those young people first.
The Japan Wagamama Awards is an educational program for teenagers in Japan. Participating began with a program for wish of one person close to them. They use MIT App Inventor to develop an app. Participation is completely free, and the grand prize winner receives our support to present their work at MIT. But Japan Wagamama Awards is not just an app competition. It's a developmental pipeline that helps young people take their first step from an unspoken wish to social action. First, we hold local trial workshops in collaboration with schools, local governments, and community organizations. Our goal is not to find only students who already have technical skills or confidence. We want to reach young people who simply feel, I want to make something better for someone close to me. Next, all students who wish to join will get online lectures and individual support for 2 months. They turn their wishes into questions and build prototypes using MIT App Inventor. In the 2026 programs, 77 students officially participated and 10 teams were selected as finalists. They came to Tokyo to the final presentations, but they wasn't the end. Japan Wagamama Awards connected them with local partners and supported real-world implementation. The entrance to this system is what we call Wagamama. In Japanese, Wagamama means is often associated with selfishness. From childhood, we are told, don't be selfish. Don't cause trouble for others. As a result, many young people stop expressing their real wishes. So we redefined Wagamama as unspoken wish, something that reveals a problem no one has noticed yet. For example, one student noticed something about her uncle, who has difficulty walking. She realized that his unspoken wish was to enjoy eating out more freely. She discovered that accessibility information for local restaurants was rarely available, so she developed an app to share barrier-free information with the community. It began with one uncle's unspoken wish. She realized that what seemed like one person's wish was actually a challenge shared by many people in her community. Our idea is simple, from one Wagamama to action. When young people begin with local social problems, they often feel overwhelmed. But when they begin with one person's unspoken wish, it becomes something they can take action. This is how we connect Wagamama with computational action. A key part of this process is the bansosha. In Japanese, bansosha means someone who runs alongside you. A bansosha doesn't give answers. Instead, they offer questions. Who are you developing this for? Why does this person matter to you? How could work with you? We call this human-centered questioning. A bansosha helps students keep focusing on the person behind the problem. Bansosha helps students organize their idea, overcome challenges, and connect with their communities. That is why we see them as relational infrastructure. We also evaluated the impact of this program. Here is a characteristic of the 77 students who participated in the Japan Wagamama Awards. There are three more female than male participants. All but 5 students came from local communities across Japan. More than 60% had no programming experience. About 40% said they were not confident in programming. And 32% said they were not good at studying. In other words, many of our participants were not students who would normally enter a programming competition. We compared survey results from the orientation and the first submission. We found significant improvements in agency, social connection, technical self-efficacy, resilience, collaborative behavior, and other orientation. But the interviews revealed something that numbers alone could not. One student said, by designing for just one person, we ended up creating something that many people could use. Another student questioned that helps me discover something much deeper inside myself. Students came to see their own wishes as actions that could contribute to society. Finally, let us return to Nanoka's story. She is still working on this project today. Her project began with her grandmother's simple wish. I want to go out carrying only my smartphone. As she explored that wish, she uncovered a bigger problem. People couldn't quickly access medical information during disasters. So she created an app. Today, she continues working with local clinics, the fire department, and city government to bring her idea into real use. She once believed that technology wasn't for her. Now she hopes to study medicine and engineering because she believes she can contribute to her community. This is computational action. Over the past few years, we've seen remarkable changes in both young people and the adults who support them. In Japan, Wagamama became a doorway to imagination, action, and computational action. We believed every culture was its own version of unspoken wish. So we'd like to leave you with one question. What word in your culture could open the same door? We want to help create a world where people everywhere can turn their unspoken wishes into computational action. Thank you for listening.
All right, thank you very much. Do we have any questions? Natalie?
I really like this presentation. I think my main question is, so the philosophy of the Wagamama Awards is they focus on one specific person, and that gets really deep into the problem that that person is trying to solve. And going back to what Laura said about the beauty pageant problems with like poverty and solving world hunger. So instead of doing that, they're focusing on a specific problem and person, and they realize that can apply to more people. I think one of the biggest successes of your program is the mentors and the banshosha. So can you talk a little bit more about how you train the mentors to teach in that direction and guide the students in that direction?
Thank you for the question. We create a curriculum for training educator. This name is Certificate Computation Action Program with MIT App Inventor Foundation team. This is 30 terms, 30 lesson. For this is first, we teach a method, Wagama lab and computation action and so on. Second, their practice in their school and in their town. They teach real workshop. And third, they are reporting their activity. And fourth, that's all 3 steps. Yes. Hi. 4 months is program, but we can arrange shorter and longer. Yes.
Okay, any other questions? Okay, hearing none, thank you once again.
Thank you.
And thank you to all of our speakers in this session.